Hi, in another exam build-up tutorial in today's session, we're of course going to consider mathematics paper 1, where we're going to embrace one of those important regular concepts, and of course our topic in today's discussion is going to be linear programming. We're of course going to target a part of linear programming which covers linear inequalities. This is where a diagram is brought with lines that are going to create the unshaded region. This usually carries about 5 marks and we can't afford to skip, especially if we're aiming for a distinction in the oncoming final exams. So we're going, of course, to offer beginner-friendly explanations that if you're looking at this for the very first time or for maybe the purpose of revising, and of course this should be very much beneficial. Ensure that you subscribe to this YouTube channel. If you're watching this on our Facebook page, leave a comment, share the video, and tag those that can find this same video very much beneficial. Let's dive in. From the graph below, then the question says, write 3 inequalities that describe the unshaded region R. So in this instance, we are firstly going to agree that this region R is bounded by this vertical line which cuts the x-axis at 2, and then the horizontal line which cuts the y-axis at 1. We also have this line that cuts both axes in the y at 2 and then in the x at 4. The first thing to do under linear inequalities is firstly to identify the line. So if we identify the line, we're going to use the axis as well as the number at which the line is cutting. So the first inequality that is ever simple is the one that cuts through the x-axis. So here we are firstly going to say x equals to, so the value at which it is cutting, that is a 2. And after doing this, I want you to best believe that under linear programming, there are basically 2 types of lines. We're going to have a solid line like this one, and then we're going to have a broken line. A broken line is going to mean either greater than or less than. This means the answer or the value at which the line is cutting is not part of the solution. Then we're going to have a greater than or equal to. This one is for solid lines, implying the value is also included. Then, having said so, we're now going to write that is x. So the simplest way to do this is that in the x-axis, to whichever side has been shaded, there will always be an inequality that faces this side. So in this instance, this is shaded to the left. Which inequality faces to the left? It is greater than, and then we're going to put 2. Looking at the nature of the line, this is going to be an equal to. How in a mathematical language can you explain this? This has been shaded to be less than 2 because the 2 is here, so which means most of the values that are here are greater than, so this is less than. So which means we want the unshaded part of this line, which is to the greater than, and we've already written greater than or equal to, which means we are already directly correct. Then moving on to the second one. The second line is this one, which cuts at 1, but this cuts it in the y. So which means we're going to say y equals to 1, then we say y. Remember, we are taking the side of the line that is not shaded. So what has been shaded is downwards, implying our inequality is going to be upwards. Upwards means greater than. Looking at the nature of the line, this line is broken, implying I'm not going to include an equal to. So this becomes, that is just a 1. So like that. And then we're also going to offer, that is a super easy explanation for the third one, where we want to see how this we need to move. So this one cuts the y-axis at 2 and then the x-axis at 4. So in the y-axis, we always start with a 0 and we end with a number. And then here we start with a number and end with a 0. So which means 0, 2 and 4, 0. There are basically many ways of finding this. You can rely on finding the gradient, the constant, as well as the y-intercept, or we can be able to say on the third one, we're going to say the value in the x is 4. So we say x and then over 4, and then plus, then the value in the y is a 2. This is supposed to give us a 1. This is also another method, especially for beginner-friendly explanations. So here, we're going to write this in the y-intercept form, which is y equals to mx plus c, where y and x are variables, m is the gradient, and c is a number. So in this instance, we're going to remain with y over 2 equals to, if we cross this to the other side, it becomes negative x, that is over 4, and then plus 1. Since we want to remain with the y, like it is in this expression, we're going to multiply the whole equation by a 2. So 2 multiplied by y over 2, it means this 2 and this 2 will cancel, so which means y equals to, then negative x over 2 into 4, it's going to be 2, then plus, since this is a whole number, 2 times 1, it is a 2. Having reached at this stage, we're going to look at the side they've shaded, so this is upwards, implying our inequality is downwards. So here we're going to say y, and then less than. After putting less than, we're going to see that this is solid, so which means equal to negative x over 2 and then plus negative x over 2 and then plus 2. So the first one here, we say this is going to be x greater than or equal to 2, then y. This one is going to be greater than 1, then y, then less than or equal to negative x over 2 plus 2. I hope these explanations help in order to add on to some of the other methods that you already have in trying to prepare adequately for an exam or build up lesson or build up revision. Ensure that you subscribe to this YouTube channel, share the video, and tag those that can find the same video very much beneficial. Till in the next session, for now, it's a very good bye.